Welcome to a quick lesson on composite transformations. Composite transformations are transformations that involve more than one transformation being applied to a function at a time. So let's read this first part out. This is important. When you're doing transformations, the order that you apply the transformations matters. For example, if you stretch it first and then translate it, the result will be different if you translated it first and then stretched it later. So the order matters, and that's important when you're graphing it. So it says here, to perform a series of transformations on a function, that means a series means a few transformations, it is necessary that you notice, number one, which transformations have occurred. So just looking at the function, you should be able to spot all the transformations that have occurred. And number two, you should be able to see the order in which the transformations have occurred. And to determine the order, begin at the x and make your way out. And this example is going to be focusing on how to do this procedure. And we're going to use the example of this function here. So look at this function and consider these 2 points above. Which transformations have occurred? Well, we can see a horizontal translation has occurred, a vertical translation has occurred. This negative here means there's been a reflection across the y-axis. This negative means there's been a reflection across the x-axis, and this 2 out here means that there has been a vertical stretch, all right, parallel to the y-axis. Those are things you should be able to spot pretty quickly yourself. Now that you've done so many functions, you should be able to notice those things right away. So I've just listed all the transformations. Now the order, and the order is important. Again, it says begin at the x. So begin here, and we're going to pretend that we began just with x squared and begin here and do the transformations in order. So this has occurred first. This is the reflection across the y-axis, and then this occurred next, which is a horizontal translation, and then this occurred next, which is two things, the reflection and the stretch, and then this occurred last because it's out here. So that's the order you would do that in. It's kind of like working your way backwards from the center. Let's apply it to the problem. Alright, so here's that example function again. We're going to take it back to the parent. So here's the parent. This is a quadratic, you see. So here's the parent function. And we're going to start changing it step by step. Alright, so we've done some of this before, but I thought it was time to do another video like this to see how you're doing with it. So here is our function. And first of all, I'm going to look at it, and I said we're going to start in the middle. So starting at the x. Starting at the x, I see this negative here. So what is the rule that you would write here? This negative is being applied to the x. So think about what the rule would look like. It's going to be, anyway, make your choice from the choices you see next. Alright, so here's the rule that occurred. There, a negative has been applied to the x, so that negative. So this, what does this describe? So now I have to fill in the words. So choose the best choice for this. It's a reflection across what? Alright, reflection across the y-axis is the correct choice. And that, if I just applied this one transformation to this parent function, it would change it to a child function. So just think of changing this one by doing this. What would the child look like? Alright, it would look like this. So just the negative x is substituted into the x. Alright, and what would the graph of that look like? So that graph would look like this. Alright, so this is a reflection across the y-axis. So imagine your regular parabola and imagine it flipped side to side like this. It doesn't matter how many times you flip it. It's going to be the same because the vertex is here. So it's kind of like you're just spinning it around there and it ends up being the same anyway. So it doesn't matter if you flip it. The end result is the same. All right, let's go to the next step. Now we're going to take that child from the last one where we applied that negative there. We're going to look at this and we're going to be like, what's the next thing that happened, right? So this happened next. So we're moving away from the x. This was first, then there's this negative 3 here. All right. Now, what is the rule? And this one's going to be a little tricky. Think about what would go in here. What would replace the x to create this? Now, think carefully about this. What would you substitute for the x to create this translation? All right, look at the choices given and choose the one you think is right. All right, this is the correct answer. This may have been a little bit confusing because you see the minus here and you're thinking, well, I should put an x minus 3 in there. But no, think about this. Think about substituting x plus 3 into here. All right, so in your mind, put x plus 3 instead of that x, and then apply the negative to it. The negative would apply to the x and the negative and the 3 and give you this. And I'll show that in a moment here if you're not quite getting that yet. Let's put in the description first. So what's going on here? This is a translation. It applies to the x. Therefore, it is what kind of translation? All right, hopefully you put horizontal. And by how many units? Hopefully it shows left 3 units. This is plus, but it's actually going to move left 3 units. So the child, let's go back to this again. We're substituting x plus 3 into this. All right? So there it is. X plus 3 has gone into that. Now that negative can be multiplied through, and you get this. And that's the function we have, negative x minus 3. So we're bringing our function, our parent, closer to this. We're almost there. We have this. Now how does this graph? Well, this was an x plus 3 right here. That rule applied. So that graph, we had that graph was going to move 3 units to the left. So it's going to end up right here. All right, move 3 units to the left. And that's weird because you're used to seeing a minus there. But the reason, again, is because of that minus there, it applies to both. So it moved this way. All right, not positive 3, minus 3. Next, all right, so what happened next? So here's where we are with the function. We've gotten this far. Now we're like, what happened next? Well, it's not the 6, because when we move out from this x, this happened next, the negative 2. Negative 2 is actually 2 different transformations. So what's the rule? What are we doing to this one? What are we doing to it? Okay, look at the rules, choose the one. All right, hopefully you chose that. We're just taking the function we have and we're multiplying it by negative 2. All right, the negative 2. Description, what does that do? Make a choice. All right, that's a reflection across the x-axis because the y values are being made negative. And since there's a 2 there, it's going to be a vertical stretch by a factor of 2. It's a 2 in front of the function, so it applies or affects the y values, and it's going to stretch the y values by a factor of 2. Okay, the child. So this, negative 2 goes in front of that, so this one's pretty simple. Just a 2 in front of that now. So we're almost at the final function here. All right, and what does that negative 2 do? It reflects it and stretches it. It's going to look like this. So instead of going up and down now it's going down. It's been reflected over the x-axis, and you notice it's a little skinnier. Every y value has been stretched 2 times lower. All right, let's do the final change. We have this child, that's where we ended. We're like, what's the next thing that happened? The 6 happened right here, plus 6. So what's the rule? Hopefully you got that. The whole function, you're adding 6 to the whole function. You're adding 6 to the whole function that we have so far. So to this whole function, we're adding 6. The description, what does that do to your graph? Right, that's a vertical translation, right? When you're adding to the whole function, it's a change to the y, so it's going to move up or down. In this case, up 6 units. The new child then is pretty simple. We just added 6, so here's that 6. There's the final function. So now we took the 1 from the last one, and we're going to move it up 6. So there it is. It was, vertex was here, it moved up 6. It's here now. It's a skinny downward pointing parabola. That's the final one. All right, so that's how we took it step by step to the final function. All right, that's kind of the level you should be at now, understanding this kind of thing. There's one on the back, so now that you're done this, work on the one on the back yourself, or work with somebody near you, work with your group. Work on this together, make sure you all understand, and then you can proceed with the rest of the assignment. Good luck.